Hello viewers, in today's class we are going to test the differentiability of this function f of x equal to e raised to the mod of x at x equal to 0, right? So let us start. Now here uh, in order to prove the differentiability of this function at x equal to 0, it means we have to check whether this function is having the derivative at x equal to 0, right? Now having derivative at x equal to 0, we have to see whether the right hand derivative and the left hand derivative of this function exist at x equal to 0, and at the same time whether the right hand derivative is equal to left hand derivative, right? Okay, so it means in order to prove the differentiability of this function at x equal to 0, we have to find the right hand derivative, then we have to find the left hand derivative, and we have to see that at x equal to 0, right hand derivative is finite, left hand derivative is finite, and both the derivatives, that is right hand derivative and left hand derivative, are equal, right? So if right hand derivative exists, left hand derivative exists at x equal to 0, and they are finite and at the same time equal, then only we can say that this function is differentiable at x equal to 0, right? So let us see whether these conditions are satisfied by this function at x equal to 0 or not. The right hand derivative is defined as a limit h tends to 0 f of a plus h minus f of a divided by h, right? So here h is a positive quantity and it is very small, right? And here this a is 0, right? Because we have to test the differentiability of this function at a is equal to 0, right? So now we have limit h tends to 0 f of 0 plus h minus f of 0 divided by h, and we have limit h tends to 0 f of h minus f of 0 divided by h, right? Now this is limit h tends to 0 f of h. So here we'll substitute x equal to h. So we have e raised to mod of h minus e raised to absolute value of 0, right? And in the denominator we have h. Now limit h tends to 0, e raised to mod of h is simply e raised to h, because h is a positive quantity. So we have e raised to h minus e raised to mod of 0 is e raised to 0, that is 1, right? So here we have 1 and in the denominator we have h. Now this limit is a standard limit, that is limit theta tends to 0 e raised to theta minus 1 over theta is equal to 1, right? So this is a standard limit, so the value of this limit is 1, right? Okay, so we see that the right hand derivative of this function at x equal to 0 or a is equal to 0 is finite and it is equal to 1, right? Okay, now let us find out the left hand derivative. So now viewers, the left hand derivative is defined by the limit h tends to 0 f of a minus h minus f of a divided by minus h, right? So here a is 0 and h is a positive quantity, right? So we have limit h tends to 0, f of 0 minus h minus f of 0 divided by minus h. Now this is limit h tends to 0, f of minus h minus f of 0 divided by minus h, right? Now here substituting x equal to minus h and then x equal to 0, we can write limit h tends to 0 e raised to mod of minus h minus e raised to mod of 0 divided by minus h, right? Okay, now e raised to mod of minus h is simply equal to e raised to mod of h, that is e raised to h, right? And e raised to absolute value of 0, and here we have e raised to 0, that is 1, right? So this limit, it becomes limit h tends to 0. Here we have e raised to h minus 1 over minus h. Now this limit can also be written as negative of limit h tends to 0 e raised to h minus 1 over h. Now again we will make use of this standard result. So limit h tends to 0 e raised to h minus 1 divided by h is 1. So here we have 1 and here we have negative 1, right? So the left hand derivative is equal to minus 1. So viewers, here we have seen that the right hand derivative and the left hand derivative both exist and finite, right? Because right hand derivative is 1, left hand derivative is minus 1, but these two derivatives are not equal at x equal to 0, right? Because 1 is not equal to minus 1. So we conclude that the derivative of this function f prime of x, it does not exist at x equal to 0, because the right hand derivative is not equal to the left hand derivative at x equal to 0. So therefore we conclude that this function is not differentiable at x equal to 0.